Hello viewers, welcome to SciTech Entertainment channel where science, technology and entertainments are combined. So based on number of requests that I'm getting on the Microfluidic channels, thank you for your appreciation and also the in comment section providing the type of information on Microfluidic channel requirement. So today we'll be doing the double split and zigzag microfluidic channels, and this is how the final setup look like. Okay, going forward. So here what we do the same way like our previous discussions. Let's close this file and create a new assembly followed by new part, and just edit this like we did, and then select the front plane, create the rectangle like we do in the previous videos. Also I prefer 20 cross 40 mm, and if you want to change the units, so here you can change the units like mm. This is there, right? So this position you can change the units and go to features, extrude boss, create a height of 1.5 mm, and it again changes based on the application or the requirement. Click on this. So this is the crucial, like important uh, like this is the important space where you have to concentrate in. So now just changing the background to white, take a line, okay. So now I'll show you an easiest way to make this uh, zigzag channels, or not only zigzag, even the serpentine channels in the easiest way. So here let's give the smart dimensions. Initially this is 3 mm, and we'll keep this also 3 mm, followed by this as 5 mm, and this can be again 3 mm. Okay, and now next thing is to create a zigzag. So we can just create a random shape initially, select, and now if you see here, this is the angle that plays major important role. So depending on the type or the application type or the mixing efficiency requirement, you change this angle. So for now I keep this as 105 degrees, and the angle between the two zigzag planes we'll keep it as 25 degrees, and it is all dependent on the application as I told previously. I'll keep this channel length as 3 mm, so we'll change this as 3 mm, and followed by this as somewhere close to, we'll keep it as double, so then it will be 6 mm. Okay, and then the next thing, and then we just select this point and control press this point, so you will see the option vertical over here. Click vertical, so automatically it takes this place, and then now if you see the angle between this and this is also 25. So if we give this 25 again, so this is like overridden dimension which is not required, cancel. So now we have just this sketch. So instead of making it line by line, constraining it each time, what we can do is go to linear sketch pattern and select the patterns that we wanted to do, and we don't want in X direction, reduce the number in X, but we want in Y direction. Okay, but in this reverse direction. But if you see the length, this is 10 mm, it is written. Okay, so this 10 mm is too far. Let's try to change it to 2 mm. 2 mm is intersecting. Okay, so let's make it close to 3 mm. So now this is not intersecting, and followed by, we can increase the number. So since already 1 is there, so we change this to 9. Okay, and this is also separated, so let's keep it as, or we can just find out the distance. Go to smart dimension, check the distance. This is close to 2.63. okay, come back, linear sketch, select the entities and give the number distance as 2.63. okay, just reverse the direction. If you can see that there's a interjunction here, that they are coincident, or they might not be coincident. We'll see once we create the number of instances. So we'll increase this to 9, click OK. Now if you see, this is blue in color, so these are easy to move. So nothing, you just hold this and connect to this. That is how it completely become a fully constrained model. Once it is there, the next thing is create another, the end line and a straight line, because we wanted to give the sample input and then split it. Once it goes mixing, followed by we can collect it in an outlet. Okay, so we'll keep this dimension as again the 25, followed by just hold control, press this hold control and select this line and make collinear. Okay, and now if you see, this is one inlet. Let's say here there's a one inlet, and the second inlet we can create it somewhere in the middle. This can be the second inlet. Okay, and then this can be the inlet. The dimensions 1.75 and 1.75. okay, and we didn't give the dimension for this. Let's keep it as 6 mm. Fine. And now one side of the design is ready. So let's say if you wanted to create an outlet, and it's 2 mm. okay, and then since this should be 2 times splitted, so we just go to create a mirror entity and then select the entities to mirror. So we need this line, also this line, also this. So all these are required for us. Just keep selecting. This. And then this is asking about mirror about what? Mirror about the center line, so that we can see this happening on the right hand. Just click OK. So this is ready. And then what we need from center is an outlet. And similarly, one outlet over here. And we give the dimension close to 2 mm. Okay, or we can increase it to 2.5 since we have a little space, or we can reduce this to 2.5. okay, so till now it is fine. And now since we have to create a channel, so let's create an offset entity, and a channel, we'll keep it as a 200 micron. Then it should be 0.1, and then it should be bidirectional 0.1. So 0.1 in two sides is 0.2 mm, so it will be 200 microns. So this is how it looks. Okay, and once you click OK, then you will see this. Then go to trim entities and trim the unwanted portions. Similarly here, and similarly here. Just create the open space, passage. So now if you see, this inner shaded region shows that it has a proper covering or without any rest over connections or extra connections. And similarly, let's remove it here. Yeah. Now if you see, again it is shaded. So this is how the important part of this session. So these are the micro passage of 200 microns channel width. And for example, if you wanted to create a fillet over here, just create a filler at the inlets. These are to avoid the stress like these are the stress corners. Just to avoid, just click OK. So now the design is ready, and the next part is go to features, extrude cut, and the channel height will maintain at 0.5 mm or 500 microns. Click OK. So this is how we see the double split, the mixing of two regions, splitting and mixing inside the zigzag channels, and the resultant will be collected from the output. So these are two inlets and one output. Now what we do is just come out of sketch, go to new part, create a new part, edit the part, select the surface. Now let's create the covering, the top covering. Similarly to the outlet. Let's give the dimensions to all of them. 1.75, 1.75 and 1.75. Okay, and now go to features, extrude boss, and let's create a height that is covering the material is 0.5 mm. This is sufficient just to make an enclosure. Click OK, and then click on this, create a surface, and now let's create the extrusions for inlets and outlet. So I'll keep it as 3 mm cross 3 mm. Similarly here 3 mm. Okay, now again we need a circle to create an inlet. So the square is the support and the circle is for inlet and outlet. Click OK, and then this is how it looks in the sketch. Go to features, extrude, and take it to the height of 3 mm, and this is sufficient, and exit the sketch. So this is how your complete chip look like. So if you want to see the internal micro channels, just click on the surface, make it transparent. So this is how the final look like the device, the microfluidic device look like. So it splits and mixes and then gives you output. So thank you for watching, and then you can save it, save as the assembly file. So followed by, if someone is preferring to 3D print it, just save as the STL and save all the parts in a single component, and then you can go for 3D printing. And thank you, that's all for today. If you're liking this content, please subscribe, share. Thank you.